how can I describe the graph? We are actually going to split it up over 2 days. So today we're going to do day 1, which is going to be page 2 and 3. And then tomorrow you'll put your graphs up on the board, and you'll do a walk around, and that's pages 4 and 5. Okay, so by the end of the lesson, you'll be able to develop techniques for sketching the graph of a polynomial from its equation. In previous courses and chapters, you learned how to graph many types of functions, including lines and parabolas. Today, you will work with your team to apply your graphing knowledge to graph more complicated polynomial functions. Just as quadratic polynomial functions can be written in standard form or factored form, other polynomials functions can be written in standard or factored form. For example, here's a polynomial in both forms. Okay, so on the left, we have standard form, just meaning it's going to have the largest exponent first, work its way down. And then on the right, we have factored form, where it's broken down into its factors. Okay? When you have a factor that's squared, you can either write it squared like that, or you could technically write it twice. You could write x plus 1 and x plus 1 twice. But it's easier just to say squared. Okay, during this lesson, you will develop techniques for sketching the graph of a polynomial function from its equation. So question number 1 says the Math America Land Carnival Company is building a new roller coaster for this year's county fair. The new coaster will have a very special feature. Part of the ride will be underground. The designers will use polynomial functions to describe different pieces of the track. Part of the design is shown at right. Your task is to guess a possible equation to represent the track and test it out on your graphing calculator. To help you get an idea of what to try, start by checking the graphs of the equations given below. Think about how the graphs are the same and how they are different. Okay? So the first one has an x times an x minus 2, which means the highest power is going to be x squared. Okay? X squared, we've graphed tons of those. Those are parabolas, right? They basically have that U shape, either opening up or down, whether they're positive or negative. Okay? And if you graphed a parabola, if it had a point on the x-axis, or it could intersect, this one would intersect at 0 and at 2. How did I get the 2? You plug a 2 in right there. What is 2 minus 2? 0. Okay, so that's where the 2 comes from. All right, this second equation has the x minus 2 squared. And like I said, that means you could write it out as x minus 2 and another x minus 2, which would mean you would have 2 twice. And you would have x times x times x, which would make it cubic. Cubics have that funny little shape with them. They kind of go, whoop. Okay. And the last one is also a cubic. You're just not repeating the 2 and the 2. This one, if you plug a 2 in here, gets you 0. And here, you would plug in a what? 3. 3 to make it 0. Okay, so your task is to use the information you found by graphing the above equations to help you make guesses about the equations that would produce the graph of the roller coaster. Below, write the possible equation your group found that more accurately represents the track needed for the roller coaster. Explain what parts of the graph match exactly and which parts need to be adjusted. Okay? So you'll notice what I did on the graph right here is I highlighted the parts where the graph is touching the x-axis. Okay? This one, it just goes through it straight. But notice right here at 2, how it kind of flattens out a little bit. Okay? And then over here, it just passes through it again the Okay, so for each of these, I just determined where is it crossing or touching the x-axis. So right here is at 0. Okay, at 0, that is just an x. Because if you plug in 0 for x, you would get 0. 0 times 0 would be 0, right? Okay. Then at positive 2, kind of flattens out. That means it's going to hit it twice. So I wrote 2, the factor for 2, which is x minus 2, because if you plug the 2 in there, 2 minus 2 is 0. And it happens twice. I could have written it like this, or I could write x minus 2 squared. Okay? You want to write it as x minus 2 squared, you totally can. I just needed to point that out and kind of exaggerate it in this example for you. And then the last place that it goes through the x-axis is over here at 3. So 3 minus 3 would be 0, so I wrote the equation, or the factor, x minus 3. All right? So these numbers is where it crosses the x-axis, and below each of them is the factor that I wrote for each of them. Does that make sense? Okay? All right. Turn over to the top of page 3. For problem number 2, it says, in this investigation, your team will investigate and determine the relationship between a polynomial function and its graph. You're going to create a presentation for your class. Be sure you include complete graphs and descriptions. Okay? So I gave each of your groups a number, right? Group 1, group 2. Okay, so group 1 is going to do the first equation, group 2, group 3, and so on. All right, your task, says you're going to create a poster. We're not going to make a poster. There's just room at the bottom. So down at the bottom, you're going to do all of these things. You're going to make an accurate and complete graph. You're going to state the degree. If it has a shape, if you can look at it and say, oh, that kind of looks like a blank, then yes, it has a shape. But there are a couple of them that are like not obvious shapes, okay? But if yours has a shape, it'll be obvious, okay? You're going to write the number of roots, and you're going to write the number of factors. So I'm giving you the rest of this page to create a rough draft of your poster. Every team member must have a rough draft. You're each going to need one in your packet. Yeah, okay, that includes all the parts above, and then bring it to me. I'll check it, I'll initial it, and I'll say good. And then tomorrow, we're going to put them up on the board. You're going to do the gallery walk, and you're going to get everybody's. Okay, so today you're just focusing on the one that's for your team. Tomorrow, you'll put them up, and you'll get everybody's. It makes it sound super hard, but they're actually kind of easy. Okay, so this is my function. I called it H for Hoban. Okay, it's different than all of the ones you have. Okay, so my equation is 0.5 times x minus 2 times x plus 3 times x minus 1 times x plus 5. Okay, this is a 4th degree because it has 1, 2, 3, 4 x's. Okay, I just went in Desmos graphing calculator, typed it in, and here is my shape. Okay, mine has very much a shape of the capital letter W. Okay, but yours might not have a shape. Okay, there are also 1, 2, 3, 4 roots, and there are also 1, 2, 3, 4 factors. Okay, that's pretty much what you're going to do for your equation.